Okay, probably last video. All right, a quadratic function, first thing you have to remember is the graph of it is a parabola. If it's a parabola, that means it's a U-shaped graph. And if it's a U-shaped graph, that means that it has a vertex. I showed you how to get the vertex in great detail in that video, but we'll go over it again here. Take the opposite of what's behind the x, but in front of the square. So take the opposite of that, so that would be plus 1. So if this was x plus 1, it'd be negative 1. If there was no number in there, it would be 0. So take the opposite of what's behind that x, and that's your x value. So it would be 1. And then your y value is always the number that's on the end, not the opposite of it. Okay, so now we said make an XY chart. Now hold up just a second. Don't copy these, because this is not how I talk. Don't copy these. But here's what we did. We put 1, negative 4 right here. So don't worry with this. Ignore that. Whatever this number is, go to 2 and then to 3. So whatever that number is, you go to the next number on the right and then the next number on the right. Now, plug this number in right here. 2 minus 1 is 1. 1 squared is 1. 1 times 2 is 2. And 2 minus 4 is negative 2. Plug in 3. 3 minus 1 is 2. 2 squared is 4. 4 times 2 is 8. And 8 minus 4 is 4. And so what we did, we didn't do these two up here. We just plotted these 3 points. So let me show you where they're at. One negative 4 is to the right, 1 down 4. 2 negative 2 is to the right, to the right 2, down 2. 3 4 is to the right, 3 up 4. So you've got that part of the graph. And then remember how we took this point is 1 space over. So 1 space over on the other side, there's another point. This point is 2 spaces over from the center line. So 2 spaces over from the center line, there's another point. So we only use these bottom 3 to graph it, which is fine. Now let me say again here. If you say, Mr. Rayner, I'm completely confused on what you just did there. It probably means you never watched all those videos. Because when we did these videos, we did about 7 or 8 of these where we just got the vertex. And then we did like 4 where we did the full graph. So I'm not teaching this as if you have never laid eyes on this. I'm teaching this as if you have watched your videos, you have taken your notes, and you have done your homework on this. So this should not be completely new to you at this stage of the game. All right, now this next one is an absolute value function. It's V-shaped. And this section, this one came from section 2.7. Now, how do we get the vertex? Take the opposite of what's behind here, negative 2. Y is the number on the end. And remember, the number in front determines whether it goes up or down. Because of this negative, it goes down. Now, you take your XY chart, put negative 2, 3 in your XY chart, and then whatever this number is, go 2 bigger. So go to negative 1 and negative 2. So, I will say again here, don't worry with these top 2. So put this point right here. Now, whatever this number is, go 1 bigger than that, then go 1 bigger than that. Now, take this number, plug it in to find this number. All right, so let's take negative 1. Negative 1 plus 2 is a positive 1. The absolute value of 1 is 1, but that makes it negative. So negative 1 plus 3 is plus 2. Now plug in 0. 0 plus 2 is 2. Absolute value of 2 is 2, but this makes it negative. Negative 2 plus 3 is 1. Then plot these 3 points. And when I plot these 3 points, negative 2, 3 is to the left 2, up 1, 2, 3. Negative 1, 2 is to the left 1, up 2. And 0, 1 is none left or right, up 1. So you put your pencil right here and go through there. Now here's your center line. This point is 1 away from the middle, so come 1 over here. This point is 2 away, so come 2 away over here and get another point to draw in that line. Okay, this next problem. First, this is what we call an exponential equation. It's an exponential equation because your variable is in the exponent. I gave you the steps in section 4.2 on how to solve this. Rewrite both sides using the same base. So I can't rewrite base 2, but I can rewrite 8 as 2 to the third. Now they have the same base, so now you set the exponents equal to each other and solve. And again, after I get through talking, pause the videos and copy them. Okay, this next 2. Our next one right here, you cover this up. The log of 16 base 2. This means 2 to what power is 16? 2 to the 4th power is 16. Log of 25 base 5 means 5 to what power is 25? 5 to the 2 power. Log of 1/9 base 3. 3 to what power is 1 over 9? Well, 3 to the 2nd power is 9, but I need 1 over 9. So make that exponent negative. Right here, the log of 1, understood base 10. So this means 10 to what power is 1, and that's 0. And then this one over here, the log of 1,000 is 10 to what power would give you 1,000, and that would be 3. So that's how you evaluate those logarithms mentally. All right, this next one also comes from 4.3. Use the properties of logs to expand. I gave you 3 properties of logarithms. And so we're using these properties of logarithms from left to right. All right, how do we take the log of a fraction? You take the log of the top part minus the log of the bottom part, and that's c to the 5th. Now, how do you take the log of something times something else? You take the log of the first one plus the log of the second one, and then minus, and then just brought the last log down. And then remember the power property for logs. If you have the log of something to a power, you can bring that power down front. Bring that power down front. Bring that power down front. And so, using the properties of logarithms, I fully expanded this right here. Okay, this next problem. Solving a log equation. So we're looking at just this right here right now. Don't worry about that over there. All right. This is from section 4.5. I gave you the 4 steps to solving a log equation. Step 1, get all the logs on one side. Here's a log term, here's a log term. This is not a log term. So I'm going to move this term over to this side. Now, how do you, and then step 2, combine the 2 logs into 1 log by using those properties. When you're adding 2 logs and you put them back together, you multiply the arguments. So when you put these together, it's this times this. 1 log, still base 3. Step 3, convert this to exponent form. So that's going to be this to this power equal that. This to this power equal that. Now distribute. This is a quadratic equation. A quadratic equation has to be set to 0. So I'm going to leave this over here and move the 9. Factor that to set both equal to 0. When you do, you get 9 and negative 1. However, remember the fourth step says, make sure the answer you find doesn't make your argument or base be negative. If you let x be 9, that's okay. And 9 minus 8 is 1. That's okay. But let x be negative 1. Then that puts a negative 1 right here, and your argument can't be negative. So we have to rule that one out. So this one only has one answer, and that's 9. Okay? This next one. Okay, this next one. This is an exponential equation because your variable is in the exponent. It's like the other one that I worked. The difference is this one doesn't have a common base. So 5 and 47 don't have a common base. So this is where we did in section 4.5 where you have to solve this one by logarithms. First, take the log of both sides. I gave you the steps in the video. Take the log of both sides. Step 2, bring the power down front. Step 3, convert your logs to decimals. So I bring down the x minus 2. The log of 5, if you take your calculator, is 0.69897. The log of 47 is 1.6721. The reason I carried these out farther spaces is, if you'll remember in the video, I told you whatever you're rounding your final answer to, carry your decimals out farther than that. So carry them out. If I'm going to 3 places, carry these out at least 4 or 5 for right now. All right, now distribute. When I distribute, I get this. Bring that down. Now get your x's on one side, numbers on the other. So I'm going to move this over to the other side so it becomes plus. Add these two numbers together and then divide by whatever's in front of x. So when you divide this, 3.07004 divided by this, you get that. Now when I wrote my final answer, I did round it to 3 decimal places. Okay, now we're getting into stuff that should be really, really familiar to you because we just now covered these. Okay, solving a system by substitution. Step 1, solve for x or y in one of these. This one's the easiest. So I'm going to take the top equation and solve for y. Move the 3x across. Step 2, substitute this into the other equation. Well, this was the first equation. So let's copy the other equation down and substitute this in for y right there. So put 1 minus 3x in y's place. There it is. And solve. So distribute. Add your x's together. Add 3 across to get x equal 1. And then the third step said, use step 1 and step 2 to find the last part of the answer. So take this number, plug it in right here. So 1 minus 3 times 1 is 3. 1 minus 3 is negative 2, and that will give you the y value. And then write your final answer as an ordered pair. Okay? Next one. And again, pause the video anywhere you need to get it copied. Okay, this next one, elimination method. Well, you got to choose what you want to eliminate first, the x's or the y's. If you eliminate the x's, 5 and 4 get both of these to be 20. If you eliminate the y's, 2 and 3 get both of these to be 6's. But remember, not only do I need these to be 6s, I need them to be opposite in sign. They already are. So to get this to be a 6, I got to multiply by 3. To get this to be a 6, I got to multiply by 2. So we're going to have to take 2 times the top one and 3 times the bottom one. I'm sorry, I said that backwards. 3 times the top one and 2 times the bottom one. When you do that, 3 times 5, 15. 3 times 2, 6. 3 times 16, 48 is negative. 2 times 4, 8. 2 times 3, 6. 2 times 22, 44. Now add the two equations together. The y's eliminate. So this is 23y equal negative 92. Divide both sides by 23 to get x equal negative 4. And then the last step was to take this answer and plug it back into either one of the original problems. It doesn't matter which one. You pick whichever one you want to pick. I took the top one. And what I'm going to do is plug negative 4 in for x in the top equation, right there. And when I do that and solve that for y, I get 2, thus completing the ordered pair for negative 4, comma 2. Okay, this next problem. Equation with fractions. First, what can x not be? It cannot be 7, because if x is 7, you get division by 0. So we call 7 your restriction. What do we do next? Get your LCD. So you got an x minus 7, a x minus 7, and a 1. So I'm going to multiply through by x minus 7 by all three of these terms. So x minus 7, x minus 7, x minus 7. This cancels, leaves x. This cancels, leaves 7. And then this distributes. Solve this equation to get x equals 7. But remember, 7 was your restriction. You can't allow any value of x that would make your denominator be 0. So, since that was my restriction, in this case, this problem has no solution. Okay? Let's see what you can and what you can't. Okay, you can. All right, pause the video if you want to and copy this one. Okay, I'm assuming you've copied it. Okay, here we go. Radical equation. Step 1, isolate the radical term. It is. Step 2, square. And I gave you the steps in section 1.6. I gave you the steps to these problems. Square both sides. When you square the left side, you're just left with x plus 14. When you square the right side, you have to do the FOIL on that. X minus 6, x minus 6. This is a quadratic equation. A quadratic equation must be set to 0. So I'm going to bring these two terms over to this side. When I do, they both become negative. Combine my like terms. X squared, negative 12x minus x is negative 13x. And then 36 minus 14 is plus 22. Factor this. It's the easy case. X and x. Signs are the same, both negative. Two numbers, if you multiply, you get 22. But if you add, you get 13. It's 11 and 2. Take and set both of these equal to 0 to get 11 and 2. But remember, on radical equations, you must check your answer. So, take 11, write the original problem back down, and put 11 in for x, here and over here, and then see if it's true. This one is. So 11 works. Now let's check 2. Write the original problem down, put 2 in here and here, and do the math. Well, this one doesn't work, so 2 is not an answer, but 11 is. So this problem has one solution, not 2. Okay, then the last three problems involves the very last video. Step 1, isolate the absolute value term on a side by itself. Next, get your A and B. This is A and this is B, and then there's the formula. Why am I using this formula? Because it's absolute value equal. So replace A with 2x plus 3. Replace B with 10, not 3. So replace B with 10. This is 10, but it has a negative with it. Now you have two equations. So subtract 3 across and divide. Subtract 3 across and divide to get your two solutions. Okay, this next one. This one is formula 2 because it's greater than or equal. Get the absolute value by itself. It is. Identify your A. That's your A right there. That's your B. Now we're using formula 2 because of the greater than or equal. Go back to your videos to see where these formulas come from. Now replace A with 2x minus 3. Replace B with 5. But this has a negative with it because that's the formula, and that's a less than or equal. Then solve each one of these separately. Add 3 to both sides, divide by 2. Add 3 to both sides, divide by 2. Then we graph and do the interval notation to that as well. Okay, then the last example. This one, get the absolute value by itself. It is. Identify A, which is this. B is this. We are now, because this is a less than, we're using formula 3. But you have to take the equal to off. So if you use formula 3 without the equal to, it's this. Now replace the A with 2x plus 1. Replace the B's with 7s, but that one has a negative in front of it. This is a compound inequality. Get the x by itself. Subtract 1 first. From the middle, from the left, and from the right. When I do, this is negative 8. The 1's add out and leaves 2x. Leaves 6 on the right side. Divide by the number in front of x. Divide through by 2. And when I divide through by 2, I get negative 4 less than x less than 3. And then the graph is everything between the two numbers. And then the interval notation. Okay, so this completes the review for the final exam. I am going to make one more video about 5 minutes long, just parting comments.